Section 1.5, Part 2. Now, these are due in the same day. It would be a bad idea for you to wait till the day of the day that it's due to start working on it. Right? At which of the following x values does the function shown below have slope 0? I think that problem is not completely worded correctly. I think that what they really mean to say is, at which of the x values does the function shown below have a tangent line whose slope is 0? A tangent line whose slope is 0. And that would be at -4 and 3. See it? At -4, the tangent line goes horizontal, and at 3, the tangent line goes horizontal. There's a picture of it. Find all the x values where the slope of the function, here we go again. Man, oh man. Find all the x values where the tangent line to the function has a slope which is negative. All right, that's going to be at this guy and at this guy. So -4 and 4. Let's look at the explanation, and they'll draw you a picture. And there's our negative slopes. Graph of a function is shown below, at which x value, here we go, finally, is the slope of the tangent line to the curve equal to 2. Okay. It's looking like it might be this guy right here. At the x value of 1. It can't be any of these over here. It can't be that one. Can't be that one. Those both have negative slopes. Can't be this one. That's 0. It's either going to be this guy or this guy. This guy is looking like it's got a slope of 1. I mean, hold a sheet of paper up to your screen and try and draw a line that just barely kisses that one point right there. It won't have a slope of 2. It's this guy where x is 1. And here they've got a picture of it for you. And sure enough, you can verify that it starts off down here and it has a run of 1 and a rise of 2. That's a slope of 2. We've got a graph of a function at which value of x is the slope of the tangent line to the curve equal to 1/2. It's got to be it's this guy, right, when x is -2. Reason being is that it's probably a slope of 1 for this point, and it's 0 right there and negative on these. So, and here would be the picture. That's a slope of 1/2. Okay. And you can see it. Trying to see where this line goes through some cross. This line doesn't go through any of these intersection points on the grid, so it's more difficult to see. Oh, look how far we are already. Find the x values where the slope of the function shown below is 0. You can't. this function does not have a slope of 0. Its tangent lines would have slopes of zeros, and that's what they have meant to ask you. Okay, and that's going to be at -5 and -2 here and here. And then we'll look at the picture. And you see that the red lines they go completely horizontal. They have slope of 0. And here they want positive slope. And again, they've said slope of the function. The only functions that have slopes are linear functions. All the other functions can have a slope of a secant line. It can have a slope of a tangent line, and here they're meaning to ask you about the slope of the tangent line. And it's only going to be this point and this point. Those are the only spots where if I stuck a line that only touched at that point, that it would have a positive slope. So that's at 1 and 3. 1 and 3. Oh, there's your picture. All right, both have positive slope. 75%. Woohoo. Here we go. Graph of a function shown below, at which value of x is the slope of the tangent line to the curve equal to 1/2. So it's got to be positive, so it's on this here side. Can't be any of those three numbers, and it's more than likely -1. It's probably a positive 1, slope right there. Ja. So when x is -1, boom, and there we can see our you can kind of see it has a 1/2 slope, because from right there, if I go 1, 2 units to the right, and then imagine that I've gone up 1 unit, then that's the best you can do with this grid. 88% mastery. It looks like this is just going to be staring at pictures. Given the graph of the function, estimate the slope of the tangent line to the curve at x equals -2. Oh boy. Let me do this. Let me get a picture of this thing. And then see if we can study it that way. I just want to get a picture of it. No, I did it wrong again. Here we go. This will work this time. This is the button to click. I don't know my own software well enough. Here we go. And they wanted me to do what now? They wanted me to estimate the slope of the tangent line at this point. Alrighty. So I know that my guy here will do lines. Whoops. Let me change to the color red and try that again. It obviously can't go like this, right? That would be a secant line. This is secant, still secant, and then, pow! Looking pretty darn tangent. And if I make one going this way, that would be secant. Actually, actually have to be perfectly aligned. So my tangent line looks something like that. Okie dokie. Then if I gotta go from right here, and I need to maneuver so that I wind up back on that line, then it's looking at first like I'm gonna rise a half a unit and run 1. Run 1, rise, but my rise is a little bit more than a half. So I might have to run 3 units and then rise 1 3/4. That's not looking good. How about I do it like this? Let's pretend it went through that grid line there. Then I went over 3 and up 2, so that's 2/3. I'm going to go with 2/3. And it's not a choice. What do you know? In fact, you don't even have to do all that. There's only one possible solution on here that could even conceivably be the right answer, and it's this one. The slope of the tangent line was not negative at all. It was not 0. And it certainly wasn't greater than 1. So the answer must just be this 1/2. Okay. Oh, we're done. Super. Talk to you later.